Today we are going to look at a different perspective of refraction, that is refraction through prism. So what is prism? Prism is a homogeneous surface of two different surfaces which is at an angle, maybe of glass. Mainly we consider prism made up of glass. So you have two surfaces inclined at an angle to each other, making an angle between them, and the material is glass. It's a homogeneous medium and that is called prism. So let's see how it looks like. So this is how a prism looks like. That is, you have a surface here, you have a surface here, then one this side and one here. So how many you have? How many faces you have for a prism? 1, 2, 3, 4, 5. So we have 5 faces for the prism. But when we consider refraction through a prism, now imagine this is made up of glass. Now we have two surfaces which is active or through which refraction takes place, and it is this surface and this surface. Light falling on this surface and this surface will undergo refraction. So this and this is called active faces of a prism. So we are not going to consider this side and this side. Now we will draw the figure, the section of the prism on the board, and then we will show how, or we will look at how an incident ray is refracted through a prism and how it comes out of the prism. So let's look at it. So this is how we are going to draw the figure. So this face is actually this face. So what I have drawn is this section. In fact, when you draw it properly, so this is, you have like this, then like this. This is how you draw the actual prism, the three-dimensional version of it. But we are not going to consider that. We are going to take this section of the prism, that is our active section. So it will have this face, and a hollow space like this inside. It's actually filled with glass. Now let's consider a ray of light incident on this face. So I draw a normal. We have a ray incident on the prism. I mark my prism A, B, C. So you have an incident ray. What happens to this ray? This ray will get refracted. It gets refracted and it goes like this. It goes in a straight line. Again, you have an interface. So we draw a normal here and the ray gets refracted again to this direction. So you have an incident ray going like this, then here and this side. So this is how the ray looks like. Now you extend these two lines, it meets at a point. I take it as E and the ray will take it as P, Q, R, S. P, Q, R, S is the path of the incident ray. A, B, C is your prism. Then this triangle, that is Q, R, E is a triangle formed when you extend the normals. Now N and this side I take it as N dash. Those are the normals. Now this angle, this is your PQ, sorry, not this angle, this angle is your angle of incidence, that is between the normal and the incident ray. Then we have the ray refracted from the normal. So this is your angle of refraction. Now here you have another angle. So that will be, if I take this as R1, this will be R2. I take it as R2. Then here we have another ray getting or going away out of the prism to the air. So this angle we'll take it as angle of emergence. So let's talk about the angles once again. You have an incident angle, angle I. This angle is getting refracted, that is R1. And I take another angle at which this goes and falls here. So this becomes the angle of incidence for this face or this interface. So that I take it as R2, and the ray going out forms an angle E, that is angle of emergence. Now we are talking about a prism. So light ray incident on a prism gets deviated. So what is deviation? Now you have an incident ray, extend it. Okay, we have the emergent ray, that is the ray refracted first and then finally going out of the prism. This is called the emergent ray. Now extend the emergent ray also. And the angle between them, that is you have the incident ray, you have the emergent ray, you extend it, and the angle formed between the incident ray and the emergent ray is called delta, or that is angle of deviation. So we are going to discuss about this deviation and hence obtain refractive index of the prism. Now we will derive the formula for refractive index of the prism. So let's start our derivation. Consider angle delta. Let's consider this triangle. I'll mark this as D. Okay. So D, we have marked B, Q, R, S. So D, Q, R. Let's consider the triangle D, Q, R. So from triangle D, Q, R, this is your triangle. Okay. What is delta? Delta is exterior angle, isn't it? You have a triangle, this is a triangle, and delta is the exterior angle. So what is delta? Delta is equal to angle DQR, angle DQR plus angle DRQ, angle DRQ. This is angle delta. Now, delta can also be written as, what is this angle? Now look at NQP, that is your angle of incidence. This is your straight line and this is another straight line. So this angle and the entire angle are vertically opposite angles. I repeat, this angle and the entire angle is vertically opposite angles and they will be equal. So this entire angle can be written as I. This entire angle can be written as I. So what is this angle? This will be I minus, this is your R1. So if this entire angle is equal to I, then this will be I minus R. So DQR is I minus R. Now plus, what about this angle? That is DRQ. The same principle can be applied. Angle E and this entire angle, they are vertically opposite angles. They will be equal. So if this angle is R2, then this left out will be E minus R2. So this will be E minus R2. So you have delta is equal to I minus R1 plus E minus R2. Let's write R1 and R2 terms together. So you will get it as I1 plus E minus R1 plus R2. This is how it looks like. This is delta. Now let's consider the quadrilateral AQER. Okay, quadrilateral. So I can represent quadrilateral like this, AQER. Now in this quadrilateral, angle A and angle E. The sum of angle A and E has to be 180 degree because opposite angles of a quadrilateral gives you, the sum gives you 180 degree. So we can write angle A plus angle E is equal to 180 degree. Now next is we will consider the triangle QER. Triangle QER. From triangle QER, triangle sum property R1 plus R2 plus E will be 180 degree. So I write that R1 plus R2 plus angle E is 180 degree. Angle A plus angle E is equal to 180 degree considering the quadrilateral. Then considering this small triangle QER, triangle sum property R1 plus R2 plus angle E is equal to 180 degree. So let's mark this as equation 1, this as equation 2 and this as equation 3. From 2 and 3. From 2 and 3, we look at both of this. Your RHS is same 180 degree, 180 degree. Angle E is also same. So what is left? Angle A. That means angle A will be equal to R1 plus R2. So angle A is equal to R1 plus R2. And this we will take into this equation. That is the first equation. We've got angle A is equal to R1 plus R2. So delta can be rewritten as I plus E minus R1 plus R2 will become A. So the equation becomes like this. A delta is equal to I plus E minus A. Now this is about deviation. Now there was an experiment practically conducted where the angle of incidence was increased and they observed what is the angle of deviation. It's an experiment performed in the lab. So the incident ray which falls on the prism not less than 30 degree. Now why I say not less than 30 degree is if the incident ray is less than 30 degree, most of the rays were found to be reflected back to air. It gave a proper refraction which could be observed only after 30 degree experimentally. So that is why we say an incident angle greater than 30 degree. So when a light fell on this surface, it got refracted and then the ray came out. Now when this was studied, as the angle of incidence was increased, the angle of deviation decreased, it reached a minimum value and then it started increasing again. So the graph looks like this. When we plotted between delta and angle of incidence. Okay, so as we will take I here, I and delta. As the angle of incidence was increased, so angle of incidence is increased, delta decreases, and then after reaching a minimum point, it increases like this, and then it keeps on increasing. This was experimentally found, and this graph is very important. Delta I graph, that is I delta graph. This is called I delta graph. So as I increases, delta decreases, it reaches a minimum point. So this minimum point is called delta M and then it keeps increasing. This is ID curve. Now, if delta M is the minimum deviation condition, then you look at it. At this point of angle of incidence, delta is minimum. Now for that value of incidence in our triangle, we had our prism, we had the ray going like this. Now this was angle of incidence and this was angle of emergence. Now at delta M, you have a particular value of I, and that is this. Now imagine it is minimum deviation that is happening in the prism. In that case, this angle E should be equal to I. Why? Because this, like you take the incident ray going like this, if you invert or if you reverse the direction of the incident ray, then this will go and come back. So at the minimum deviation point, I will be equal to E. This is because you can take the same path backward and still you will get that condition. That condition exists, minimum deviation exists only for one angle of incidence. So I put it on this side or that side, it has to be the same angle of incidence. This is the reason why I say at minimum deviation point, angle of incidence and angle of emergence will be the same. So, to write about it, we can write at delta m, that is at minimum deviation, I is equal to E. Now, let's apply the refractive index formula. M is equal to sin I by sin R. So, for the first phase, that is, for the first side, this is your angle of incidence, this is your angle of refraction. For this side, if it comes from this side, E by R2. So you can also write this as sin E by sin R2. I and E are equal. So R1 and R2 has to be equal. So we can write R1 is also equal to R2. So now let's go back to our equation of delta. So what is delta now? Delta is equal to I and E are equal. So I write it as 2I minus A. So the equation of delta becomes 2I minus A, where delta is equal to delta M. This becomes delta M now. It's no more deviation. It's now minimum deviation. So delta M is equal to 2I minus A. So what is I? I is equal to delta M plus A divided by 2. So this is equation of I. Now we are supposed to find out the refractive index of the prism. And the formula for refractive index is N is equal to sin I by sin R. That means we should know what R is. Now we said R1 plus R2 is equal to A. Now R1 and R2 are same. So I take it as R1 is equal to R2 is equal to R. Now that means A is equal to 2R. So what is R? R is equal to A by 2. Now we have two equations. That is I is equal to delta M plus A by 2 and R is equal to A by 2. So what can we write about our refractive index? N is equal to sin I is this. So delta M plus A by 2. And what is R? R is equal to sin A by 2. So this becomes the equation of refractive index of a prism. So what did we do, children? We have taken minimum deviation formula, and in minimum deviation, what are the condition? Angle I is equal to angle E and R1 is equal to R2. From that, we obtained what is I and R and then substituted it in the refractive index formula, and hence we obtained the refractive index of a glass prism. Thank you.